All right, we've given time to everybody else, so I guess we're going to have to talk about solids just a little as well. The solid state can exist as either a crystalline or a amorphous state. So, sorry, keep doing that. So the crystalline state is just what it sounds like. It's a crystal. It's a regular arrangement of particles. And so, like, I'll draw one because this is the only thing I can draw. A cube. Okay, all right. So it has a repeating structure. So like it's in a nice symmetrical shape. Then we have what's called an amorphous solid. And an amorphous solid has no regular arrangement, but it's a solid because they're very closely packed still. And remember, solids are not going to have a lot of movement. And so they just kind of sit there and vibrate unless they're put in water or something like that. So there are 4 types of crystalline solids: ionic solids, molecular solids, network solids, and then metallic solids. So an ionic solid is made up of, guess what, ions, okay? And a typical example of an ionic solid is sodium chloride or table salt. And so you have alternating sodiums and chlorines in this nice symmetrical pattern. And remember, all of these are crystalline, okay? A molecular solid is composed of molecules that are arranged regularly, like water does when you freeze it, okay? They just kind of line up, but they're not really, not as ions, they're still as the individual molecules. A network solid is a network that is lots of atoms that are covalently bonded together. And so the silicon dioxide is the example that they're using here. Very geometric, and you can see, and when you look at it, it's going to look like a crystal. A metallic solid is what we call a lattice solid. A lattice, if you've never seen how a lattice is in a fence or whatever, you know, like some people have them like under their porch, like their back deck or whatever to hide their lawnmower and everything. That's a lattice. All right, and so lattice is metal cations, and they're surrounded by a cloud of electrons that are going to be moving around. And so that makes them very reactive, and so that's why metals are very reactive. And so our example here is copper, which is a pure metal. Now the amorphous solids don't really have a regular arrangement. They're just packed very closely together. So they can be formed when we cool solids down too quickly for them to get their nice regular crystal pattern. Very large covalent molecules also tend to form these amorphous solids because they can get all twisted around each other. Examples of amorphous solids are rubber, glass, and plastics.